Today we'll be looking into module 4, okay, which is your Earth segment, right? So all this while we were discussing about the uplink, right, the downlink, and the connections involved between them, the antennas, the kinds of noise that can occur, right, and the various surface parameters, okay, the flux densities, and TWTA. So all these were our points of discussion. So in this module, okay, we will be discussing exclusively about the Earth segment. So when I say Earth segment, it's about your base station and what are involved, what components are involved, and how we will get things worked out. Okay, and there are, as I mentioned in my previous lecture, okay, there are a lot of block diagrams, okay, wherein you can refer to them, and uh, accordingly it could be understood in a much better manner, right? Okay. So this is the introduction, okay, to your module, where the Earth segment of a satellite communication system consists of transmit and receive Earth stations. Okay. So when I say communication, okay, communication just cannot have the transmitter section and uh, cannot, just have only the receiver section. So it should be in combination of both transmit and the receive sections, right? So we need to have both of them, and so together it can be called as our communication system, right? The simplest of these are the home TV only receive systems. Okay, so we will be discussing about these home televisions and what kind of block diagrams are used for these. Also included in the Earth segment are those stations which are on ships at sea. Can you tell me one example? Okay, as soon as you hear this statement, can you tell me one example of one situation where we had employed uh, this particular situation? Can one of you recall wherein we had exclusively used this for our satellite program? Can you recall? ISRO had used it. Any clues? Any thoughts? So during the launch of Chandrayaan, okay, so they had used the ships exclusively. They had used ships in order to communicate, okay, because due to the bad weather, they could even place the satellites, and the antennas, the big antennas, could be moved from one place to another place. So just go through the documentary of Chandrayaan, okay, wherein you'll be able to understand as to how these ships were employed, okay, how the ships were employed at the sea for the purpose of communication. So they had employed ships in different countries, and as they launched the satellite, okay, they were able to communicate via these ships. Very interesting documentary. I think you all should go through it, right? And commercial and military land and aeronautical mobile stations. So these are some kind of ways in which we can host or we can use our satellites. So satellites can be employed on ships, in the sea, okay, and the commercial and military land and aeronautical mobile stations. So these also can be used. One group of Earth station consists of fixed and mobile. So which means I will have a fixed antenna, and also I will have a movable antenna. So one movable antenna can be a ship, okay, which is used in maritime. Then this can be employed in ground, maritime, aero, handheld type of antennas, then in railways, okay. So all these can be a part of your earth station. So when I say earth station, okay, it means that it's not just a lab setup, okay, in some remote area, but then it can be a group of antennas which are placed, which are grouped apart, okay, but working for the same functionality, right? So the other type of grouping that we can see is the DTH, okay, which is receive only, okay. So normally in our television systems, do we transmit anything to the satellite? Students, you can unmute and respond. Do we transmit any information to the satellite while watching the television? Yes or no? Anisha, do we transmit any information to the satellite from the television? Anisha Devi?
Sir, no, I think.
No. Okay, it's a no. Because we are just streaming information, right? We are just streaming, which means we are tuning and we are receiving information from the satellite. So that's the reason, we call it as receive only. Fine. Reporting the data platforms like automatic weather stations or deserts to measure temperature, etc. Okay, so this will be only transmit, okay, because they are collecting information and they are sending. We don't have to send any information to these stations. They are collecting and just pushing the details to the satellite. So these are transmit only. And when we are in need of information, then that becomes receive only. Receive only, right? Next, there is another group of satellite called VSAT. Okay, so this can do both. It can send information and also it can receive information. Okay, right. So Earth stations that are used for logistic support of satellites, such as providing telemetry, tracking, and command. In short, we know it as TTNC, are considered as part of space segment. Okay, so we will be employing these kind of transmit and this receive in satellites, and that is going to be a part of TTNC. Okay, telemetry, uh, tracking, and command. So this is used for our space segment. So in space communications, we just cannot transmit information and stay idle without receiving any information, right? We need to transmit as well as we need to receive the information or signals. So which means we need to have a duplex kind of communication. So the next one that we'll be looking into is the DBS, okay, which is direct broadcast satellite. So this is a planned broadcasting which directly we get to the home TV receivers. Okay, so this in place in the KU band, okay, which is about 12 gigahertz band range, and this service is known as DBS. Okay, so the reason why it's called a direct broadcasting is because you directly receive signals from the satellite. Initially, if you can recall, we had these antennas which were placed on top, and we used to adjust these antennas. So due to which the picture quality and the voice clarity wasn't good. So due to the recent innovations and changes and the regulations that happened, okay, in the field of communications in our country. So we were able to move on to a digital platform where the broadcasting also became better, and the audio quality also improved with a much drastic change, right? Okay, so direct broadcast satellite refers to satellite TV systems in which the subscribers or end users uh, receive signals directly from geostationary satellites. Okay, so that's a very important point where you receive information how directly. There is no other medium of receiving the information, and these are received from what kind of satellites? From geostationary satellites. Okay, fine. Signals are broadcast in digital format at microwave frequencies. So all these that you find here are all microwave frequencies. DBS is the descendant of direct-to-home satellite services. So it's a part of your DTH, okay, DTH services that we all are having. DBS, direct broadcasting satellite, is a type of satellite used for consumer services, such as transmission of radio and television. So even in radio, initially we were employing AM signals, but right now we go with FM signals, right? And in the field of television, okay, we go with MPEG 4, okay, which is a much better picture quality. We have resolutions of 4K, 8K. So the only thing is the content is to be developed. Okay, so the reason why we call it as 4K HD, full HD, there's a difference between HD and full HD, which HD runs at 720p, and your full HD runs at 1080p, right? Um, and 4 times it is your 4K, 8 times it, okay, 8 times of full HD is your 8K. So as uh, the resolution increases, okay, you can blow up the video, or you can put it up on a bigger screen wherein the clarity doesn't get disturbed. You do not find it to be grainy. Okay, if you can recall the salt and pepper concept, okay, wherein you would have studied this in your DSPs and MATLAB. So these wouldn't be available, okay, just because of the techniques that are employed in our televisions. Okay, so which is capable of transmitting and receiving high data. Okay, so not only just receiving information, but it is having a communication. Okay, it is streaming, and it is trying to extract a lot of data from the satellite. So as your resolution changes, so the way it extracts or streams or downloads data is also at a higher rate. Okay, fine. So the next thing that we'll be looking into is the block diagram. Okay, so this talks about the receive only home television systems. So you can see that in the block diagram, this is the antennas that we normally place in a terrace, right? And this is called a parabolic reflector, and the range used is about 12 gigahertz. So you can approximate it to about 12.5 gigahertz. Then you will have this receive horn. You would have seen it actually attached to your dish, right? And it is called receive horn and polarizer. Then after that is your LNA, okay, low noise amplifier, because it needs to amplify the signals, okay, and noise has to be kept in check. So these signals, okay, will come down, and you can see that the range is completely different now. The frequency range from gigahertz, it has changed to megahertz, 950 to 1450 megahertz. So these signals will pass through, and we will have an amplifier inbuilt, This is actually your receiver. I can say that this is your set-top box. Okay, so all that is inside your set-top box. Did you know that you can stream FM stations also using your set-top box? Students, were you aware of these concept wherein you can stream your FM stations also?
No, sir.
Yes, actually, service providers should be enabling this feature on our set-top box. But due to the bandwidth, what they do is they try to cut it off. Okay, wherein we cannot hear FM stations. Right, so this is one thing that you can all keep in mind. Actually, it has a FM module and it also has an AM module, right? So wherein you can tune your set-top box to receive these signals. Okay, fine. So the amplifier, and then you have your tracking filter and down converter. So whatever information that is being passed from your amplifier gets passed to your filter. And then you have something called IF, which is nothing but your intermediate frequency. So this will take about 70 megahertz, and you will have an FM demodulator, AM remodulator. Okay, here you have a channel select and display. So this is where your tuning happens. Okay, you have tuning oscillators here, tuning circuits, wherein actually you are tuning to a particular frequency, but there for your user interface, they would have given channel number, okay, maybe 111, something like that. So that is actually tuning to a particular frequency. Okay, so that job is done by this tunable oscillator. So as it is tuned, okay, you can see that there is a feedback here. Okay, there is a link here which actually tells or it takes from the amplifier, and accordingly that station comes up and immediately your IF gets connected, FM demodulator AM, and then the signal passes through your televisions. Of course, these days we do not have these kind of televisions. It's all flat screen. Olden days we used to have this cathode ray tubes television. Okay, right. So this is how your home television systems do function. Okay, wherein you have your reflectors. Okay, these signals are actually coming from the satellite. Okay, all these signals are coming from the satellite, and you have a converter. Okay, I can say that it's a down converter. Okay, it steps down your frequency from this range to your megahertz range, and ultimately these signals are passing through your blocks of communication. You can see one more thing here, that there is a line that is separating your indoor unit and outdoor unit. Okay, so the one below this line is all your indoor unit, the one that you keep inside your house, and the one that you see above this line is all your outdoor unit. So this is the thing that we keep in the terrace. So this is our connecting wire, okay, that connects our outdoor unit to indoor unit. So this is the black cable, okay, that you can see. Fine. So any doubts here, students?
Sir,
Hmm.
for parabolic reflector, it should be in particular direction to receive from satellite, no, sir?
Exactly. Now the reason why we do that is actually, it is like receiving proper signals. So when you see, your engineers will come with a small, your installation engineers will come with a small device, okay, wherein before connecting it to our home unit, what they do is they connect the wire, okay, just clear this. So what they do is they connect this wire, okay, this wire, they connect it to the device, and they try to check as to how much of percentage is your signal received. If your signal received is greater than 90%, okay, then they will stop adjusting this parabolic reflector. If not, they will change the direction. Probably they will move it this side, or probably they will take it a little higher, or maybe they will change this angle. Okay, so here you can see that there is actually a small lever, okay, which can hold the dish, and it can be rotated and it can be fixed accordingly. So 90% and above is something, where we are targeting. So once we receive these signals, then this is screwed and this is kept in place tight, so that the direction of this dish doesn't change. And then he disconnects the device from here, okay, and the cable is connected, and then it goes to your setup box. From the setup box, it gets connected to your television, right? So any doubts
Yes.
here? Can I proceed?
Yes, sir.
Okay, fine. So in this manner, we try to make sure that we get the maximum signal possible. And see, ultimately, if we do not tune this, or if we do not adjust this antenna, okay, the receiver, then always you will not get proper signals, and then the quality of your reception also does change. We cannot achieve 100%. Keep that in mind. 100% is not at all possible. 100% signals you can never receive. Okay. Only that you can receive the maximum amount of signal, and whatever received, this processing happens here, and we try to nullify the noise and give a pure signal to the television. Pranay, you have a doubt? Your hand is raised.
Sir, what if that parabolic reflector gets any dust or something? It will not
Uh,
receive any signal.
Actually, what happens is, this is very much important. Okay, this section is very much important. Okay, so this is ultimately a metal piece that you see. Okay, so it is made in such a way that all the signals that are falling on it converges and gets into your horn. Okay, all the signals converges and gets into the horn. So it's like, these signals are all distributed, but once it gets into the horn, I want it to be laser focused. I want it to be laser focused. So unless that part is taken care, okay, then that is fine. Most of the time, what will happen, the only part that gets damaged is not your parabolic reflector, but then you will see that your receiving horn gets damaged, probably in 10 years or 8 years, something like that. So they make it more robust, okay, because there is a lot of rain, there is a lot of dust, as you suggested, and there is a lot of sunlight. Okay, so it needs to uh, go through with all this harsh environment, right? So max, probably about 5 years is the life of this polarizer, okay, the receiving horn. So this full thing will be replaced actually. So today, once you all go back home, okay, or once you get time, you can go to your terrace and just look at these modules that are connected, so that practically you will be able to understand as to what I'm trying to explain. Okay, I think you would have seen this. Probably you wouldn't have analyzed it. Correct?
Yes, sir.
Yeah. So now, once you see this unit, okay, you should be able to remember what all we have learned so far. So any doubts, Pranay, or anyone?
No, sir.
Okay. So can we move on?
Yes, sir.
Fine then. Right. So whatever we discussed so far is actually mentioned here for your benefit. It's a planned broadcasting, okay, which happens directly to home TV receivers. and this takes place in this range. The service is known DBS. There is some variation in the frequency bands assigned to different geographic regions. So which means we cannot use the same frequency which is used by India, or probably we cannot use the same frequency that is used by neighboring countries, right? So which means what I'm trying to say is the frequencies used by our country will be unique to ourselves, and there will be slight modification in the frequency, the signal frequency used by our neighboring countries and the other countries, right? So that we tune to a particular frequency. See, when I say tune to 91.9, exactly you should be tuning to that 91.9. If you tune even to 90, 95, okay, 95, then you will not be receiving the signal that you intend to, right? But then you'll be receiving some other station. So we tune to a particular frequency and we make sure that our receivers are tuned, or our set-top box is tuned to perform these operations. Okay. So many times, I don't know if you have observed, there will be a firmware update from our service provider. Okay, you can see it on your televisions. Please wait, do not turn off your set-top box. Update in progress. How many of you have seen this? Have you all seen it? This kind of message displaying on the television? Yes. So what happens is during this time, okay, the software that is inside your set-top box actually keeps updated, gets updated. So these are all programmable, okay, and as per the latest regulations that the government gives in, so accordingly these softwares are pushed. Sometimes what happens is there will be bugs, right? So they will keep working on optimizing their code, and once it is done, okay, they will push it to all the setup boxes. Right. There is some variation in frequency bands assigned to different geographic regions. Fine. The comparatively large satellite receiving dishes, okay, rather in diameter from about 1.83 meters to about 3 meters. So this can be the range, okay, of our satellites. Okay. So it can be about 6 feet to about 10 feet also. Okay, such huge diameter antennas. Okay, satellite receiving antennas, which may be seen in some backyards, are used to receive downlink signals at C-band. Okay, so receiving happens at about 4 gigahertz. Originally, such downlink signals were never intended for home reception, but for network relay to commercial TV outlets. Okay. So if you can remember, previously we used to use this cable connections, and those big dish, okay, those big antennas used to be in that cable provider's terrace, right? You all recall that?
Yes, sir.
Yeah. So from there, it used to be down converted, those frequencies, okay, this 4 gigahertz that you see, used to be down converted and distributed to all the houses nearby, right? So that was a kind of analog transmission. But right now that we are employing is digital transmission. So these signals, okay, are downgraded, and the 4 gigahertz signal is actually uh, made suitable for home transmission. Okay, right. So any doubts here? Can we proceed?
Yes, sir.
Okay. Fine. Much of the television programming originates at first generation signals, also known as master broadcast quality signals. So initially, whatever signal that comes through, okay, that was termed as master broadcast quality signals. So these signals used to be without any distortions, which means the high quality, the first hand signal. These are transmitted via satellite in the C band to the network, uh, head-end stations where they are retransmitted as compressed digital signals. So normally what happens when you compress things, okay, certain quality, or I can say much of the clarity and quality is reduced. Why do they do this? Can someone tell me as to why compression is employed? Why is compression employed and it is retransmitted?
Sir, to decrease bandwidth.
Yes, good, to save bandwidth, because bandwidth is very important. So the more you compress, the more the signal quality reduces, and the amount of bandwidth needed for this to transmit also becomes less. But what happens is, with the quality also, we shouldn't take a lot of hit. So for that reason, what we do is we employ a lot of techniques, okay, algorithms, where even though the um, signal capacity is less, okay, even though it is compressed, but still it should be enhanced, okay. So those kind of algorithms will be employed, and that is what comes down as a software update to your setup boxes. One of the advantages claimed by sellers of C-band equipment for home reception is that there is no loss of quality compared with the compressed digital signals. So these advertisements, okay, these advertisers, okay, they try to claim that the equipment that they are selling, the C-band equipment, um, captures the best information, and there is no loss at all. But practically speaking, okay, that doesn't happen. It is in fact compressed, and it is sent. Although many of the C-band transmissions are scrambled, there are free channels that can be received. It's like how we do have certain channels, even though you don't pay for it, okay, you can view them. Okay, just like how in the previous days we used to have the Doordarshan channels, right? So there are few channels, okay, which are free. And what are termed as wild feeds. These are also free but unannounced programs of which details can be found in advance from various publications and internet sources. So these days we do not have to worry about all this wild fields and all this stuff, because they have categorized things based on the types of packages that we are going to employ, and based on that the pricing plans are also prepared, right? Okay. The major difference between Ku band and C band receive-only systems lies in the frequency of operation of outdoor unit and the fact that satellites intended for DBS have much higher EIRP. So if a question is asked, differentiate the Ku band and C band, okay, so this is going to be your answer. So the most important thing that you have to concentrate here is EIRP. Okay. So your EIRP levels are different for both Ku band and C band, and also your frequency of operation. The frequency of operation is also different. Right. Now, talking exclusively about the outdoor unit alone. Okay, remember this outdoor unit was at the top section, right? Here, this. So this section we will be discussing right now in detail. This consists of a receiving antenna feeding directly into a LNA or a converter combination. So sometimes it used to be only low noise amplifier, and then it used to pass through a converter. But then right now you have a combination of both in the same block. A parabolic reflector is generally used with the receiving horn mounted at the reflector. For satisfactory reception, the diameters are chosen from zero point 0.6 to 1.6 meters. Okay, so ours are just in the range of few meters. Okay, but if you see those satellites, okay, satellite antennas, okay, as I told you, they can range even up to 10 feet, okay, in diameter. So the reflector diameter for 4 gigahertz C-band reception can range from 1.83 to 3 meters. So as your frequency increases, okay, your range also of this there's a difference in the range as per the frequency and the diameter of the antenna. So accordingly, all these are done with permutations and combinations, and the best range is selected with respect to the diameter of the antenna, with respect to the frequency, and how much distance that the signal is able to travel. The downlink frequency band of 12 to 12.7 gigahertz spans a range of 500 megahertz. So this is capable of accommodating about 32, okay, 32 TV or FM channels. So as I told you, even FM channels you should be able to uh, view or hear, each of which is about 24 megahertz wide. Okay, so each channel is about 24 megahertz wide, and this can accommodate about 32, okay, TV channels. So now you can probably do a small math, okay, and try and understand as to how much of frequency that is needed, okay, how much of bandwidth that is needed. So if a range is about 500, we'll have to even employ this guard bands, okay, in between each channel, so that there is no ISI, inter-signal interference. Right. The receiving horn feeds into a low noise converter, or possibly a combination unit consisting of low noise amplifier followed by a converter. So as I mentioned previously, okay, so this can be in combination. Okay, it can directly pass into a low noise converter, or it can be a combination of an amplifier and then a converter. Okay, so two things here. So if your low noise amplifier and converter are together, okay, then we just term it as low noise converter. Okay, if they are separate, okay, then we term it as LNA and then a converter. Okay, fine. The LNB provides gain, which is nothing but your low noise block. Okay, low noise block. So sometimes it's also referred to as low noise block. So the LNB provides gain for broadband 12 gigahertz signal, and then converts the signal to a lower frequency. So here what is happening? Down conversion is happening, as I mentioned previously, to a lower frequency. So which means a down conversion is happening, so that a low-cost coaxial cable can be used as feeder to the indoor unit. Now, this is also important. You know why it's important? Now, if I have to use a higher frequency of range, then the quality of coaxial cable also needs to be better. Okay, but if I use a lower frequency, okay, then I can use a normal coaxial cable, and the communication can just happen, right? So there are a lot of parameters that comes into picture, okay, when we try and understand the transmission of signals. So the standard frequency range of this down converted signal is, as we saw, 950 to 1450 megahertz, right? Okay. So the low noise amplification must be provided at the cable input in order to maintain a satisfactory signal to noise ratio. So low noise amplification, okay, you saw a small amplifier there, right, connected. So that is nothing but your LNA, low noise amplifier, must be provided at the cable input in order to maintain satisfactory level. Having to mount the LNB outside means that it must be able to operate over a wide range of climatic conditions. Now, this I have spoken about, isn't it? How your climate changes. There is a drastic change in the climate. Suddenly, the sunlight, the heat, the rain, the wind, the dust. Okay, so it should be able to withstand all of these situations, right? And homeowners may have to contend with the added problems of vandalism and theft. So not only that, sometimes due to theft, okay, sometimes someone just steals off your uh, antennas. Okay, right. So I think we will stop here, okay, up till the outdoor unit, and we will continue with the indoor unit and its specifications in detail, okay, in our upcoming class. So students, any doubts that you have so far, the concepts that was discussed?
No, sir.
Okay, so fine, then we will catch up in the next class and continue our concepts with regards to the indoor unit.